Hi guys, Miss Murphy again. I hope you're doing all right. Today's lesson is going to be on making unit conversions, particularly metric conversions. In science, whenever you have a number, you need to have a unit of measurement behind that number, right? And we use the metric system. We talked about this, meters, liters, grams, right? You need to have your number, and then behind your number, you need to have a unit that tells us what that number is referencing, okay? So you can't just write, the answer is 100, and say 100 what, okay? I just want you to remember, I haven't said that in any of my videos yet, so, units of measurement, what are you measuring this in? Are you measuring your time in days? Are you measuring in weeks? So we need to know this. You must communicate this, okay? A lot of what I'm teaching you is how to communicate in science, all right? Important. Okay, so we're going to look closer at the metric system, particularly making conversions, converting between units. Say I have meters, I need millimeters. Say I have millimeters, but I need meters. So we're going to convert, and we're going to show a little bit more than just moving that decimal. We're going to actually learn how to utilize a T-chart, okay? A T-chart, yeah. So I'm going to flip over to my camera and get into metric conversions, unit conversions. Hopefully we'll get to dimensional analysis. We'll see. All right. All right, guys. Here we are back in the classroom. Let's see. Metric or unit conversions. All right. It's always good. You're on a piece of paper to try to give yourself a title. Unit conversions. Okay. Particularly, as I've said 3 times already, the metric system. Now, chemistry, physics as well. A lot of units and a lot of converting units. Some formulas require certain units, so you have to be able to convert one unit into another very easily, okay? Now, this is your abbreviated general formula. You're going to always start with the number and the unit that's given, okay? We'll give an example, of course. You're then going to, I'm going to give you 2 options because you're going to see me utilize both options, or, okay? And what I'm teaching you is something called the factor label method. All right, you are learning the factor label method of converting units. This is also referred to as dimensional analysis. All right, that is what we are looking at today. And it's simply fancy words for unit conversions, all right? And what I'm doing over here is I'm giving you 2 different ways that you can show your work, all right? Some students will go like this, all right? And they call that a T-chart. You could probably see why. And some students will go like this. It means the same thing, all right? Whichever way you like, use. You see how this is pretty much the same thing as that, right? But instead of drawing the lines like that, you just kind of put this, okay? This is how we're going to organize our work, okay? I'm always going to start with the number and unit given. That's the number and the unit that I need to change. I need to get a new unit for this number. I'm going to write the unit I have down here, okay? I did not write number. I just said unit. And I'm going to write the unit that I need up top, okay? Up top, all right? The reason, I'll say that in a minute. I'm then going to I'm going to insert conversion factor. numbers. This is where our numbers are going to come from. All right. And I would write the same thing right here, but I'm not going to write that again. Okay. I can do this as many times as I need to. I will give you an example of what I mean by that. Okay. So I'm going to back up. I'm going to go like this. And I'm going to give you an example. And we're going to start extremely simply. Okay. I also encourage you, and I'm going to write it over here real quick because I can. King Henry's daughter buys dark chocolate milk. Remember, we talked about that last time. You need to have that here. You need to have that available. Okay? So if you need to press pause and you need to go get your chart right there, which I told you to rewrite over nice and neatly. All right, let's go back to our example, guys. Let's see that we've got 50.0 milliliters. And I need to know how many liters is that. Okay. Some of you guys can start moving decimals. That's all fine and dandy. You need to be able to show your work, and we're going to step that up a bit this year. Okay, guys? No more just going up and down the hill. I'm going to write the number in unit that I'm given right here. Okay? Just like it said, the number and the unit given. This is what I'm given, right? And this is what I need. If you're confused, this is the number and this is the unit. It tells me 50 what? 50 milliliters of space, all right? Okay, so I wrote the number and unit given right here. I draw my T chart, whichever version you want. And then according to the directions that we just wrote down, it said to write the unit needed. No, it doesn't. That's not what it said. It said to write the unit you have. Well, this is the unit I have, so I'll write it right here. And then our notes say to write the unit that we need right here. Well, we need liters, okay? All right. Now we're going to add to our notes. And we're going to see that this is the metric system, right? We notice the metric system here. And if you're like, what is the metric system? Milliliters and liters. Because what we need is our conversion factor, right? Because the next step in our note says conversion factor. Well, let's see. I should have started with a different example. Okay, so what we're going to do next is we're going to put a 1 next to largest unit. This is not the only way to do it, but it is a way. And as a teacher, I have to give you a way. I can give you another way, but I have to give you a way. Let's pick the largest unit and give it a 1. Well, the largest unit is the liter. So I'm going to give it a 1. Okay. Then we're going to figure out how many times larger it is than our other unit. Okay, so I'm going to go and use my metric system chart. I'm at liters. Liters is a base unit. It does not have a prefix. I am right here. Okay, I need to be, actually this is where I need to be. Okay, I am currently at milliliters. This is where I need to be. I'm sorry, I keep saying that wrong. This is where I am. This is where I need to be. They gave me milliliters. They asked for liters. Okay, well, remember we said that this was 10 times bigger, 10 times bigger, and 10 times bigger, right? So in order to get from here to here, according to our notes, we have to times 10, times 10, times 10, and 10 times 10 times 10 is 1,000. So if I were to have 1 liter right here, that would be equivalent to having 1,000 milliliters right here. Okay, 1,000 milliliters right there. Now let's finish this problem now that I have the number and the unit that I need, and clean it up for you visually. We'll press an equal sign. Okay, and I don't have the number and unit I need, I have the unit I need with a conversion factor. Now I'm going to treat this like a fraction. I'm going to multiply everything on top. That is 50 times 1. That equals 50. All right, but let's take a look at our units. I have a milliliter times a liter. It's a milliliter times a liter. I'm doing this every step I could possibly imagine, okay? I have multiplied the top. I will now divide it by the bottom. So I'm going to put 1,000 milliliters right here. Milliliters cancel, right? You can see that that cancels. And the answer is 50 divided by 1,000. That is going to give me 0.05. These values are significant. I need to keep them. Okay? So 50 milliliters is equivalent to 0.0500 liters. This is the same amount of space. I have converted milliliters to liters. I started with the number and the unit given here. I put the unit that I had here. I put the unit that I needed here. I said this is the metric system. I'm going to give the largest unit a 1. Liters is bigger than milliliters. So I'm going to put a 1 right here. I'm then going to figure out how many times larger it is. And I'm going to put that number right here. I'm then going to multiply across, press equals, divide it by the bottom, press equals, and I'm going to cancel my units that are the same on top and bottom. And I'm going to make sure that my answer makes sense, and it does. Now, is that the only way? No. That is the way to do it when you put a 1 next to the larger unit. Does it have to go there? No. Does it change things? Yeah. You don't figure out how much bigger, figure out how much smaller, okay? But you don't need to think about 2 ways, just get 1. Let's do another example. Let's say that this time we have 7.5 kilo, 7.50, significant figures, kilograms, and we want to know how many grams is that. Okay, well, let's do the same steps. Let's start with the number and the unit given. Let's draw our T-chart or our lines. Let's put the unit that we have on bottom, the unit that we need. Actually, we can do grams. Unit that we need on top. Okay. Let's recognize that this is the metric system. So since I'm in the metric system, I'm going to pick my larger unit. That's a kilo. And I'm going to look at how many times larger. And once again, I'm going to see that it is 1,000 times larger. Because I have the unit that I need, I'm going to stop and put my equal sign. Okay. I'm going to see that kilograms is on top and kilograms is on bottom. Those will cancel. The only unit left over is my grams. I'm then going to multiply the top, all of the numbers on top. That'll give me 7,500. And I'm going to divide it by the number on bottom. And that will give me 7,500. However, this is where, and that is grams, this is where students start to make mistakes in chemistry. This value right here has 3 significant figures. So my answer over here, it needs to have 3 significant figures. My only option here is to put this number into scientific notation and to take that decimal and go 1, 2, 3. And I end up with 7.50 times 10 to the 3rd grams. I can't take a measurement that has 3 sig figs and make it into a measurement that only has 2. That's not appropriate. Okay. A lot of students make mistakes right there. A lot of students make mistakes right there. Now, oh my goodness gracious. Such a dork. I'm going to come back to you here. Okay. So as you look through this, I'm doing simple steps. Okay. Simple steps. Keep it simple. Follow the procedure. All right. I don't know how long this recording is. I'm going to end it and make another one. Okay. Okay.